Okay, so in order to calculate term n, we've seen several approaches. We've used a number approach, we've used a simultaneous equations algebra approach. So I just want to show you another approach for solving for term n. So let's just make up a quadratic sequence. Start anywhere, let's start at say 11. Let's jump up any particular amount, let's jump up 7, bringing us to 18. Now I've just jumped up 7. Let's jump up 9, bringing us to 27. Let's jump up 11. So what I'm doing is I'm moving forward by a linear sequence. Let's move forward 11 to 38. So you see let's start analyzing the situation here. My first difference here is 7. My first difference here is 9, and my first difference here is 11. My second difference is 2 and 2. Now that's fine, and we know from before. I'll just show you the other ways we have done this. We have said half of that is 1n squared. We've worked our way back here to 5, and then subsequently back here to 6, and put 6 here, and then we've added a 1 and a 6 and taken them away from 11, giving us 4n, and indeed that is the correct answer. Then there is the way where you go 1 plus bn plus c should be 11. Actually plus b plus c, because this is 1, and when you fill in 2 you get 2 squared, which would be 4 plus 2b plus c equals 18. Okay, and that's b. We'll write the system again with letters on one side, numbers on the other, and we have b plus c equals 10, and 2b plus c equals 14, and we'll subtract up the way, we'll get b equals 4, and then c equals 6, and they indeed do match with what we have here. And of course, but we probably agree with numerical method, and by the way, sequences are in the number strand. So I think certainly the specification does expect us to use number, but certainly the algebra method works. But here's an easier way again, and if this is challenging for you, I have a really cool thing to show you here. So what we're going to do is we're going to bring our calculator into statistics mode. Okay, so that's option 2, statistics mode. Okay, and then we notice here that there is a quadratic sequence here at option 3, so we're going to go for that. Okay, and now all we need to do is fill in this first 3 coordinates, which are 111, 218, and 327. And then the calculator is just going to tell us that this is the answer. Okay, so cool. Okay, let's do that. So basically, obviously, you're just going to go 1 equals 2 equals 3 equals. Forget the frequency, it doesn't really matter. So head down in order to head up. And we're going to go basically 11 equals 18 equals 27 equals. Great, data's filled in, hit AC, and you hit options. And all you got to do is take the regression. Don't worry about what is regression. Well, I can tell you very quickly. It is that if you have a lot of dots, like this, it will try and make a parabola, a quadratic, to fit them. But if you've only 3, then it's not. There's no statistical element to it. That determines. There's only one perfect. It's not best fit or anything. There's only one quadratic. So head into that, and there you go. Here comes the numbers. It tells me straight away. Hey, now I will say that the A has been swapped with the C, and the B remains the linear term. So what this means is the solution is n squared plus, from the bottom you can go n squared plus 4n plus 6, and I think you're going to find that a really cool way of doing it, and it might even be quicker if they don't stipulate what technique you should use. So guys, I hope you enjoyed that. As always, I'll see you in the next one.